Alright folks, welcome back to another Math Notes videos. This is 9.1.7. We're talking about radians today. Radians is another way to measure an angle. We're sort of used to degrees. We're used to splitting a circle up into 360 little bits and calling each of those a degree. Well, radian is another way to define an angle, and one that's actually used pretty commonly in math and engineering, as well as science. So a radian is defined as the ratio of the arc length to the radius for any sector of a circle. So the ratio of the arc length to the radius for any sector of a circle. A central angle with a measure of 1 radian intercepts an arc with length equal to 1 radius of the circle. The circumference of any circle is 2 pi r units, so the corresponding radian measurement is 2 pi r divided by r, which is just 2 pi. Thus there are 2 pi radians in a complete circle. And we can sort of tackle this as a unit conversion problem. So we know over here in degrees, 0 degrees is 0 radians. I'm going to put degrees on the inside and radians on the outside. We know that if we go half a circle, that's going to be pi radians, or 180 degrees. All the way around is 360 degrees. Gets us back to the start, which is 2 pi radian. If we go up here, this is halfway between 0 and pi, so this must be pi over 2 radians, which is equivalent to 90 degrees. And if we go in the other direction, halfway between pi and 2 pi, that would be 1.5 pi. We can write that as 3 pi over 2 radians, which would be 270 degrees. The most common conversion factor to use, although you could use any of them, would be this point right here, where you have pi degree, or pi radians equals 180 degrees. And once you treat this like a conversion factor, you can use it to convert between radians and degrees. So if we say wanted to know, pick a simple one here, 45 degrees, and we wanted to convert that to radians, we have a degree on the top of the fraction and a degree on the bottom of the fraction now. So those would cancel out. My new units would be radians, so this would be 45 pi over 180 radians, and I can reduce 45 over 180 to 1/4, and usually we'll just write that as pi over 4 radians. You could go in the other direction with this. You could take, say, 7 pi over 6 radians, and now I have radians on top, and I need to cancel that out, so I need to put my pi radians on the bottom of the fraction, my 180 on the top. Now the radians will cancel out, and I'll be left with the answer in degrees. So I can write that as 7 pi times 180 over 6 pi. We have a big 1 there. Those pi's cancel out. 180 divided by 6 would be 30 over 1. So then that just leaves us with 7 times 3, which is 210 degrees. Alright, so I'm going to leave a couple for you guys to do down at the bottom. I would like you to convert to either degrees or radians, depending on what the starting unit is. So in number 1, we have this in radians. We'd like to convert that to degrees. Number 2 is in degrees. We want to convert it to radians. Number 3, we're back to radians. We want to convert that to degrees. And number 4, we have in degrees, and we want to convert to radians. And just to leave you with something neat to think about with this whole definition of a radius, I pulled up a little animated GIF that shows the relationship between the radius of a circle and the number of radians in the circumference of a circle very nicely. And we'll watch that go a couple times. Alright guys, I'll see you next time.